All right, so today we're going to talk about finding roots, zeros, and multiplicity. So the goal at the end of this section is you will be able to analyze polynomials and identify the following things. So domain and range and behavior, turning points, zeros, and the effect of multiplicity. Okay, and hopefully we will be able to graph these things as well. There's a couple of vocab words that you need to know. The first one is roots. You may have heard this before whenever we talked about quadratics. It's the point at which the function crosses the x-axis. And I think this is so cool. I just found a lightsaber as a pointer. I'm very excited. But it crosses the x-axis. These are also called zeros, x-intercepts, and solutions, and I will use those interchangeably. The next is turning points. We have discussed those. Those are your maximums or minimums. The next one is multiplicity. This is how many times a root occurs. So a root can occur twice, 3 times, or once. It can occur multiple times, and however many times it occurs, that will affect the graph. So down below, I've given you a sketch, a visual representation of these vocab words. So those points in blue, again my lightsaber, these are your roots, your zeros, your solutions, whatever you want to call those. The maximum is this guy right up here, which is called a turning point, but this is specifically your maximum, and then this guy is your minimum. Okay? All right, now that we got the vocab down, let's look at some examples. So you can identify the roots by graphing. So you're given this function here, x cubed plus x squared minus 2x. I plugged it into Desmos. This was the graph that I got. The roots are where the graph crosses the x-axis. So right there, there, and there. So your roots is when x equals -2, 0, and 1. Okay, so pretty simple to identify the roots by graphing. It's where it crosses the x-axis. Getting a little bit more difficult, we can also find the roots by factoring. Factoring is coming back. So if you are not comfortable factoring, please send me an email and I can definitely help you out. But we are going to find the roots by factoring x cubed minus 2x squared minus 15x. So we can take out a greatest common factor of x, and that will leave us with x squared minus 2x minus 15. So now I can factor this part of my polynomial. Okay, so two numbers that will multiply to -15 but add to -2 are going to be -5 and 3. So my factored form is going to be x minus 5, and x plus 3. Now to find the roots, you set each factor equal to 0. So my first factor is x, I'm going to set x equal to 0, x minus 5 equal to 0, and x plus 3 equal to 0. And I'm just going to solve. So x equals 0 is already solved, so that's one of my roots. X minus 5, if you add 5 to both sides, you will get x is equal to 5. That's the second root. X plus 3, subtract 3 from both sides, and you will get x equals -3. So your roots are x equals -3, 0, and 5. So that's how you find your roots by factoring. Now let's talk about multiplicity. How many times does a root occur? If I were to solve this by factoring, okay, I would factor out an x, that's my greatest common factor, and I would get x squared minus 6x plus 9. Well, now I can factor this part of my polynomial, two numbers that will multiply to 9 but add to -6 is -3 and -3. So my factored form is x minus 3, and x minus 3. Now, I can also write this as x times x minus 3 squared, okay? That x minus 3 happens twice. Now, in order to solve, I have to set each factor equal to 0. So I have x equals 0, x minus 3 equals 0, and x minus 3 equals 0. I'm doing both of them. Okay, so x equals 0, that's one root. Add 3 to both sides. You will get x equals 3. That's the second root. And then same thing for this last one. You're going to get x equals 3 again. So your roots is x equals 0 and 3, but at the 3 there is a multiplicity of 2. That root happens twice, and you know that it happens twice because of this squared here. Okay? Okay, so now we're going to talk about the effect of a multiplicity. It's a great way to know what the graph is doing at those zeros. So if the multiplicity is odd, then it will cross the graph. Okay? So then the graph crosses at the 0. If the multiplicity is even, then the graph bounces at that 0. So I have my same equation that we just did. We factored it. We found that our zeros were 0 and 3. And at 3, there was a multiplicity of 2. Okay? So at 0 here, that's technically a multiplicity of 1. So it will cross at that 0. Okay? At 3, that's the multiplicity of 2, that will bounce. Okay, it kind of bounces off your graph. And so that's the effect of the multiplicity. All right, we're almost done. Let's look at some examples. So I have f of x is equal to x plus 7 squared times 2x plus 1 times x minus 4 cubed. Now I could write this out as x plus 7 times x plus 7 times 2x plus 1 times x minus 4 times x minus 4 times x minus 4. Okay, that's that function all spread out. So you can find your solutions by setting each factor equal to 0. Okay, so I'm just going to do x plus 7 once. If I subtract 7, I will get x equals negative 7. Well, since I have it squared here, I have a multiplicity of 2. Let's look at our next factor. I have 2x plus 1 is equal to 0. So subtract 1, you get 2x is equal to negative 1, and x is equal to negative 1/2. Okay, and that one only happens once, so technically your multiplicity is 1. Now let's do the x minus 4. If you add 4 to both sides, you will get x is equal to 4, and that one happens 3 times, so you have a multiplicity of 3. So here are your zeros. You have negative 7, it's a multiplicity of 2, and since the multiplicity is even, it will bounce on the graph. Next, we have our 0 of negative 1/2. The multiplicity is 1, okay, it only happens once, and it will cross at that 0. My next 0 is 4. It has a multiplicity of 3. It's an odd multiplicity, so it will cross at that point as well. Okay, now I want to show you one where you have to factor in order to find your zeros. So I have x to the 4th minus 2x cubed minus 8x squared. So I can factor out a greatest common factor of x squared, and I will get x squared minus 2x minus 8. Now I can factor this part of my polynomial two numbers that will multiply to -8 but add to -2, and that would be -4 and +2. So my factored form is x squared, x minus 4, and x plus 2. If I set each factor equal to 0, I will have x squared is equal to 0, x minus 4 equals 0, and x plus 2 equals 0. Now, where does the multiplicity happen here? It happens at the x squared equals 0, because technically I have x times x equals 0. So I can set each one equal to 0, and so I have it twice. Okay? So the first one, my 0, let me change colors here because I'm kind of running out of room. My 0 is at 0. It has a multiplicity of 2 because it happens twice. It's an even multiplicity, so it will bounce on the graph. Next, I have x minus 4 equals 0. So if I add 4 to both sides, I'm going to get x is equal to 4. My 0 is 4. It only happens once, and so it will cross. Last, I have x plus 2 is equal to 0. If you subtract 2 from both sides, you will get x is equal to -2. So your 0 is -2. It only happens once. It's an odd multiplicity, so it will cross. All right, last section. A polynomial has a 0 at -6 with a multiplicity of 2 and at 2 with a multiplicity of 1. Write a polynomial function in standard form that could represent this function. So in this case, we are going to work backwards. So if I know that it has a 0 at -6, I have x equals -6 with a multiplicity of 2, which means that it happens twice. Then I have a 0 at 2, but it only happens once. So what I'm going to do is I'm going to work backwards. I want to get my factors. Okay, so I'm going to get this function equal to 0. I'm going to add 6 to both sides, and I know that it happens twice, so I'm going to square it. Okay, same thing on the other side. With x equals 2, I'm going to get that equal to 0, so I subtract 2 from both sides, and I know that that one only happens once, so I'm just going to only write it once. So my function can be x plus 6 squared and x minus 2. Now they want this in standard form, so I have to multiply this all out. Okay, so I have x plus 6 times x plus 6 times x minus 2. Okay, so if I multiply, I need to FOIL. If I FOIL x plus 6 times x plus 6, this is what I get. X squared plus 12x plus 36. Okay, and then I multiply all of that times x minus 2, so I'm going to do some distribution here. So I'm going to multiply my x times everything there, and I will get x cubed plus 12x squared plus 36x. Then I will multiply the -2 times everything. Okay, and then I'm going to line up my like terms. So I have -2x squared minus 24x minus 72, right? Yes. I'm going to add my like terms. Last step, you will get x squared. Sorry, no, you will get x cubed plus 10x squared plus 12x minus 72. This could be your polynomial function for a 0 at -6 with a multiplicity of 2 and at 2 with a multiplicity of 1. Okay.